Under the tab for Packet-Based Attack Protection, there are different tabs that let me configure the firewall to drop different types of packets that are malformed or unusual. Under the IP Drop tab, I can select the option to drop spoofed IP packets, and the firewall checks its routing table to determine whether a packet has been spoofed. I can configure the firewall to drop abnormal packets by selecting Strict IP Address Check. These abnormal packets might be ones that have the same source or destination IP address as the network interface, or they might match the network broadcast address or a loopback address, or match a link local address, or an address that's been reserved for future use. If I select the unknown and malformed IP options, the firewall will drop packets that contain specific header options or unknown or malformed options. For example, if the packet contains an invalid protocol number in the IP header. Depending on your environment, you can select the remaining options as needed. The Web Interface Online Help explains these options in more detail, and you can search the Paloalto Network's knowledge base for articles about packet-based protection. Under the tab for TCP drop, I can enable protections against specific types of TCP packets that can be used for reconnaissance. By default, the TCP SYN with data and TCP SYNAC with data are checked. SYN and SYNAC packets should never contain data. The Mismatched Overlapping TCP Segment option watches for certain evasive techniques that use overlapping segment numbers in a sequence of TCP packets. Checking this option here instructs the firewall to strip out the TCP timestamp for packets that use different timestamps on multiple packets for the same sequence number. By default, the firewall is globally configured to drop the first TCP packet in a new connection if the packet contains payload data but does not include the SYN flag. You can override that global behavior within a zone protection profile to accommodate an asymmetric routing path that prevents the firewall from seeing the entire client-to-server and server-to-client flows. The situation is rare and usually involves running a pair of redundant firewalls in an active-active configuration or when using load balancers in front of firewalls. In those architectures, the same firewall interface might not see the first SYN packet, but might see and then drop remaining TCP packets with data. You can select No for Reject Non-SYN TCP, and the firewall will allow these data packets to traverse the zone. The default behavior for asymmetric path is to drop TCP packets that fail additional checks to confirm that packets are received in the correct sequence order despite an asymmetric route. If you have asymmetric routes for specific zones and traffic is being incorrectly dropped, then you can set the asymmetric path option to bypass these additional checks. Under the ICMP Drop tab, you can configure protection against specific types of probe packets that rely on ICMP. ICMP Ping ID 0 configures the firewall to drop ICMP packets with a type value of 0. 0 is the type value of an echo reply, and no ICMP session should start with an echo reply. ICMP Fragment drops ICMP packets requesting fragmentation, and there are very few legitimate reasons for an ICMP packet to be fragmented. ICMP Large Packet greater than 1024 drops ICMP packets that are larger than 1024 bytes. ICMP carries small data payloads that are typically fewer than 1024 bytes, so this option can be enabled to prevent ping of death type attacks. Discard ICMP embedded with error messages, and these ICMP packets can be safely dropped, so this option should be enabled. Suppress ICMP TTL expired error drops packets that inform an IP packet sender that their IP packet was dropped because its time to live value reached 0. This is not necessarily an attack or probe packet, but it can be used as one. Traceroute commonly uses this method to trace the network path to a host. However, the TTL expired message can also be used maliciously to determine the path to a host. You need to determine per zone if TTL expired messages create a security problem in your environment. Tracing the network path to an internal host could be a form of reconnaissance, and it could be considered a security risk. Suppress ICMP frag needed. This drops need to fragment messages. An IP packet sender can set a don't fragment flag on an IP packet, and these types of packets can be used to determine the path to a host. Again, you need to determine per zone if these messages create a security risk in your environment. For IPv6, the default selections shown here are the recommended ones to start with for most environments. If you use IPv6 in your environment, you need to determine whether to enable the other settings on a case-by-case basis. The online help pages explain these packet protections in more detail, and there's an article on zone protection profiles available in the knowledge base. For ICMP v6 drop, you'll need to determine whether to drop these types of packets on a case-by-case basis. The first 4 options typically are safe to enable and will not result in dropped legitimate traffic. However, if you select a specific type of ICMP v6 packet to drop, all packets of that type will be dropped by the firewall. In addition to dropping these types of ICMP v6 packets with a zone protection profile, you can configure security policy rules to allow or deny ICMP v6 traffic between specific sources and destinations using the IPv6 ICMP application in a security policy rule. The online help provides more details about these types of ICMP v6 packets, and you can consult the knowledge base for additional information about zone protection profiles.